As we start letter C, let's do a bit of word association with some of the keywords in the question that can help us understand where we're supposed to get this info from. Letter C asks us first to find x-coordinates of any point where the graph of G has a horizontal tangent line. So let's focus on what we already know about that phrase from first semester, as we've done lots of questions that have horizontal tangent line as part of the vocabulary. The phrase horizontal tangent line refers to the slope of G, specifically where the slope of G would be 0, because that's what something looks like when it's horizontal. Its slope is horizontal, slope is 0. Those are word associations we're familiar with. So when we say slope, we're really saying G prime. And when we say the slope is 0, that is a literal way of saying G prime is equal to 0. So I want to think about that and ask myself, okay, what does that mean? Where is G prime equal to 0? I don't know anything about G prime visually, because the only visual I know is the graph of F, but I can use that key fact that I came up with on my scratch work from the previous question. Anything about G prime is really just talking about F. So I'm going to make this translation. Instead of saying G prime is 0, let's make a substitution. Let's talk about F being 0. They are the same after all. G prime is the same as F. So G prime of 0, no, that's not helpful. Let's talk about where F is 0. And this, of course, makes us think about things like line charts. Zeros are definitely a main feature of a line chart. When we do minimum and maximum, those are also line chart questions. So even though I'm thinking a couple of steps ahead, I'm thinking a line chart might be a useful tool for this question, because that line chart can not only help me answer this first part about the horizontal tangent, it can also help me answer things about min and max. So I'm going to take this time right now to just set up a line chart that I can use for everything. Now for this line chart, I'm going to label it G prime, but I'm also going to write F there to remind myself that's where I'm getting this info from. It's a line chart about G prime, but I'm using the F function to help me get all the information I need. The line chart does have some implied boundaries just because the graph has some implied boundaries. The graph seems to start at -4 and end at 3. And the original question did give us that interval, so I'm going to mark those boundaries on my line chart. Now I'm going to do what I always do for line charts, which is look for zeros. And again, since I'm looking at the graph of F in order to tell me these zeros, I'm taking the graph really literally. I'm just looking for y coordinates of 0. So when I look at my graph, I'm just going to start to see where I have zeros. It looks like I have a 0 here at -1. So on my line chart, I know that -1 has a 0. I can mark that. I look again and I see another 0 at +1. So again, I can mark that one. And then as I look back at my graph, those were the only two that I saw. So those are the only two places where I have zeros. Those are the only two values where the function value was 0. Therefore, those are the only two values where G prime is 0. Remember G prime, F, same thing? If F is 0, then G prime is 0. So G prime must be 0 at -1 and 1. Therefore, G prime must have G prime must be 0, therefore horizontal tangent line at -1 and 1. So you'll see I'm purposely kind of sounding out my logic so you can follow the train of thought here. F of 0 means G prime is 0. G prime is 0 means we have a horizontal tangent line. So I can answer the first part of the question right now, that we have a horizontal tangent line at those two x coordinates, at x equals -1 and x equals +1. If it asks you to justify, you can say in a sentence, because the value of G prime is 0 at those two x coordinates, and the value of F is 0 at those two coordinates, or any sort of wording that kind of gets to the same idea. Now, for the second part to the question, I need to know about G having a max or a min. And the only way I'll know that is if I do the pluses and the minuses in my line chart to be able to kind of compare things. So, going back to my graph then, I know that I can get pluses or minuses for a line chart by looking at the y coordinates. Pluses come from where the y coordinates are positive, and minuses come from where the y coordinates are negative. So as I look at my graph, I can see that everything from -4 to -1 has positive function values, so positive y coordinates. Those will all be pluses there. Everything from -1 to 1 has negative y coordinates, so minus signs there. And everything from 1 to 3 still has negative y coordinates, so everything looks good there. Now I'll think about my line chart in the context of the g function, and I'll start to use vocabulary that hopefully sounds familiar to those of us who have done these problems before, increasing and decreasing. If I think about this function when it starts at -4, whatever it's going to look like, that function is going to start out increasing, because that's what the pluses mean. The pluses mean that the original function g must have increased. Then it must have hit a flat spot at -1 and turned around to decrease. I don't know how far, I don't know exactly what that looks like, I just know that it happened. Now it decreased for a little while until we got to +1, and then it went flat again because of the zero slope, but it seemed to continue decreasing. And even though I have no idea what the function was supposed to look like, I can infer it probably looks something like that. So now I want to think logically. If I think logically about -1, I can infer that it must be a relative maximum. It could be the absolute maximum, we're not really sure, but it's definitely in the running to be a possibility. And that's usually what relative max is all about. Relative max is just, is it a possible high point? And it definitely is. So I know that in terms of my answer, g definitely has a relative maximum at -1 because of the behavior of the curve on either side. It's going up, hits -1, then it's heading down. We can also tell from the line chart, anytime you have a curve that is going plus, then 0, then minus, we know that that 0 must be a possible relative max. So I will say, again, as part of my answer, that we have a relative max at x equals -1. Again, in terms of justification, you can easily put that into a sentence. It has a relative max at x equals -1 because the value of g prime, or the value of f, switches from positive to negative at that value. Now, 1 doesn't seem to show any sort of indication that it's either a max or a min. If I think about it, it can't be a max because obviously the curve is much higher than that point at 1. And it can't be a min because the curve definitely keeps going lower than 1 as well. So 1 seems to be neither a max nor a min. There's no conclusion we can make about its significance since the curve just doesn't seem like anything is happening. And you can tell the line chart doesn't switch at 1. Usually possible answers that I'm looking for occur where a switch happens. And I don't have a switch. It's minus and then minus. That doesn't jump out to me at all. So 1 is pretty insignificant. And if they ask me to specify, I would simply say we have neither a max nor min at x equals 1. And again, if you had to justify that in a sentence, you would say, well, it's because the sign of g prime didn't change at 1. The sign of g prime was negative and then negative, no change, therefore not a max or a min. Now that we have that understanding, though, let's just kind of put in perspective the idea that we didn't really actually have to do any calculus there. We did a line chart, of course. We analyzed calculus, but even then, we weren't doing any calculations. We were just analyzing a graph. The calculus was knowing that the graph was indicative of g prime. That was the part that we had to know. But in terms of actual antiderivatives or derivatives or real calculus stuff, nope. It was all analytical. So as long as you understand the connections between g prime, f, and the graph, then you should be able to answer these questions without doing a whole lot of work. In the last question, we'll look at a point of inflection and how we can, again, use minimal work but analysis to help us understand where an inflection point can come from if all you have is a picture.